the first question you were to answer for homework was to identify the primary producers. Primary producers are the ones that are not consuming anything and are the ones that are being consumed. If you notice, coming away from pseudonychia, let me go to some green. There's a lot of things that consume it. So that makes it primary producer. Okay. Now, standing away from that would be your primary consumers. Primary consumers are those individuals that are feeding on producers. So the anchovies and sardines, razor clams, mussels, and krill are all primary consumers. Now, secondary consumers are the ones that are feeding on the primary consumers. So notice the squid feeds on the krill, making it secondary. The anchovy is eaten by the sea lion, secondary. Same thing with the pelican. Salmon consumes on sardines and anchovies, secondary. Humans in this particular food web are secondary. Now you may be thinking, wait a minute, humans eat salmon. Well, this is just looking at a particular food web in a small area, okay? So we're just, all we're concerned with is the flow of a particular toxin in this particular area, Monterey Bay. Toxin we're looking at is domoic acid. So for the purposes of the research in this activity, humans only eat razor clams. That's just to let you know, so to avoid confusion. Sea otters would also be secondary, as with crabs. Now, as far as tertiary, third level consumers, they eat second level. Seagulls would be that way, orcas, and you could even say that the sea lion, because it feeds on the squid, could also play the role as a third level. I don't know why I wrote twos. That makes no sense. But third level. So there's only 3 trophic levels in this particular food web that was studied for this activity. All right. That answers question number 3 for you. Now let's move on to question number 4. I got to zoom in here a bit. Okay. Question number 4. Let's take a look here. It says that producers in this food web are estimated to have a productivity value of 9,000 kilocalories per square meter per year. Now the primary consumers have a productivity estimate of 1,500 kilocalories, so much less. So you're asked to calculate the efficiency for this. The efficiency for this is basically going to be a percentage. So how would you go about calculating this? Anybody have an idea? If you're going to do a percentage, what do you think is going to be involved? Connor? That's it. Good. And then, of course, we want to convert that to a percentage by multiplying it by 100. Now, if you go ahead and do that math, the answer you'll come out with is about 16.7%. Who remembers from the notes, typically when you go from one trophic level to the next, what percentage makes it to the next trophic level? Well, that's how much disappears, but how much makes it? So it would be 10%. Very good. So notice that this particular trophic level, or this food web, seems to be more efficient than the average food web. Okay. Now, Lauren, here's yours. consumers have a productivity estimate of 12 kilocalories per square meter per year. Okay? It's asking what percent makes it up to the tertiary consumers from the producers. So, what do we do here? Not quite. It is going to be a division. We're given 12. We want to know how much of that comes from that. So we have to go our producers. Producer value is way over here.
9,000 times 12.
It's actually a lot easier than that. It's actually the same exact problem, only asked a different way. 12 divided by 9,000 times 100%. This comes out to be, I believe, 0.13%. So the point there is the efficiency up to the third level consumers is very poor. Okay, it does not transfer, not much energy makes it. Okay, now, question number 6. Why does the amount of energy decrease as you move through the trophic levels? Look, in the producers we had 9,000. In the primary consumers, 1,500. In the tertiary consumers, only 12. Why does the amount of energy decrease as you move up? Well, there's less biomass, but there's less biomass because there's less energy to support it.
Yeah.
Where did the energy go?
Yeah,
So it's gone. Think of the second law of thermodynamics that we talked about yesterday. The second law of thermodynamics says that energy is lost to entropy. It's unusable. It's gone. Okay, so it's lost to entropy. It's gone. All right. That takes care of the food web question. Now let's go down to the biomagnification question.